Hi, have you watched the Netflix latest TV show called The Squid Game? It's really cool. You should check it out if you haven't watched that already. But more than the show, I'm interested in the memes that are popping up every now and then relating to that show. And one of the interesting memes is this one. So here's what I thought. Why not take Bleed AI logo and embed it inside this candy and make it look realistic. So I was going to do that with Photoshop and paste it on my Facebook page, but instead what I thought, why not instead use Python and OpenCV to create an automatic script that takes any image or logo and embeds it on this meme, and it would be an automatic meme generator using Python and OpenCV. So the end goal is to make it look somewhat realistic and also make it work on any logo or image. So you don't have to use Photoshop or any other editor for every new image. So that was the goal. So this is what I did, and I ended up with very interesting results, and it's a really simple process. So this is what we'll be doing in this tutorial. So make sure to stick around and let's get started. So this is the code that I'll be using for this tutorial. Again, the code is really simple, and I've added a bit of things to improve the results even further. And you can even build on top of this to get even better results. And so yeah, so what we're going to start with is we're going to import the required libraries. Importing OpenCV, NumPy, and Matplotlib. So that is all that you need to import and start with. So once that is done, I'm going to next use OpenCV's imread function, cv2.imread, and read an image. So this is the candy image that is going to serve as our input image. Then I'm going to specify a matplotlib plot size, and then I'm going to display the image using matplotlib. Here I'm reversing the image channels because matplotlib usually displays the image in RGB and while OpenCV reads in BGR, so you need to reverse the channels. So this is what this piece of code does. And furthermore, I'm giving the image the title, turning off the axis, showing the image. This is the usual drill that I do when I work with OpenCV and Matplotlib. So this is the input image. As you can see, it's an image that is stacked with two separate images. So what I need to do first is I need to work on this part of the image. So this is the second half of the image. So what I'm going to do now is extract the second part of the image and separately, and then give it a name. So this is what I'm doing here. I'm getting the height and the width of this input image, and then using the width, I'm extracting the second half of the image, which is this candy part. So this is what's happening here. I'm splitting the image in half, and you're getting the candy image part, this part. And then what I'm doing is I'm displaying this new image which I just created here with Matplotlib. So let me just run this. And this is the part. So you see, while extracting from the image, I specified that I need the full height, but for the width, I specified that start from the mid of the image and go all the way to the end. So this is the syntax, explanation for that. So and for by doing just that, I got the candy part of the image. So now I have a candy image, and this is the image that I need to I need to do two things. The first thing I need to do is get rid of this umbrella. So for that, I'll be using some blurring. So I'll use blur like Gaussian blur or a median blur, and then I'll get rid of this umbrella. And the second part of this tutorial is to paste another logo on top of this smooth image. So for that, for smoothing out and using blurring to get rid of this umbrella, what I'm gonna do is I'm gonna again now get the new width and height of this candy image. And then using the width and height again of this candy image, I'm going to again go into this image and get this exact ROI. So this is the squared area where the umbrella is present. So I'm going to go even extract even further this specific part of the image where the umbrella is present. So this is what I'm doing here. I'm getting the umbrella part from this candy image by doing this sort of an extraction. So I tried a couple of parameters, and then I landed on the exact ROI coordinates to get and extract this umbrella. We can even further automate this sort of thing. For example, you can do an object detector to detect umbrella shapes, and then by doing that you can automatically get the ROI. And similarly, you can use a color detection, and then you land on the central part of the whole image, or you can do, like if the image is whole, you can do circle detection, half circles and whatnot. Then you can extract the center point of that, and from that you can add a constant radius and get that. So there's a lot of ways to automate parts of this stuff. Right now I like kept it really simple. So by getting the umbrella part, the next step is to like get rid of this umbrella part. So for that I'm using median blur. I tried Gaussian blurring, but median blurring is giving more interesting results, and it's working much better. And there is a reason for that. Median blurring like replaces the pixels in a different way, and the way it does that, it's much better for this particular scenario, because we just need to like paste the smoothed area everywhere inside this ROI box. So that is why like median blurring is really appropriate for this type of scenario. If you need to read more about different smoothing techniques in OpenCV, make sure to go over this page. But in fact, I've even covered this a lot in detail in my course, image processing course. So if you want an in-depth explanation on which technique to use when, make sure to go over to that course. I might also release a YouTube tutorial. I don't know about that yet, but like I do that. Anyways, so after you're done with the blurring and you have a blurred image, what you can now do is simply replace ROI part, this original part, with this new blurred part. So this is exactly what I'm doing here, and let me show you the results here. So I'm replacing the the original part of the image with this blurred part, and this is what this looks like. And yeah, so this is what this looks like. As you can see, the umbrella is completely vanished from there, and this is the final results. But this is all fine and all, but there is an issue here. Along with the umbrella, you also lost the texture, original texture in the image. So as you see in the original image, this is the original image, this is the umbrella, right? But there's some texture here, and this is the texture. And so we're losing all this texture that makes the candy maybe look real or not. So you can also go along with this, and this is all fine, but why get rid of the umbrella while also retaining the original texture on the candy? So this is what this piece of code does. So when I get the blurred part of the image, instead of replacing the whole image with the blurred version like I did here, what I'll do now is I get the edges of the umbrella. So I do canny edge detection to get the edges in this ROI and get the umbrella part. And then what I do is I create, enhance the edges by, dilating the edges by a 7x7 kernel, iterating over 4 times. So this is, you can get rid of, if I do this, like if I do 30, I can get rid of most of the texture, and the results of this image will look the same as this one. But if I work with 4 iterations and a 7x7 kernel, and I get a mask. So this will be a black and white binary mask. So yeah, so here I will add another line here. And so this will display the mask along with this image. And so yeah, so this is the image and this is the mask that I got. If I replace this mask with the original edges, and so this is the edges here, and if I replace this edges map with the mask, you will see that it's a lot thicker. So the lines are a lot thicker, and this is sort of necessary because I want to make sure that I get all the parts of the umbrella. So I can make it less thick and get more texture back, but it's a trade-off between making sure you get rid of the complete umbrella and retaining the texture. So it's a sort of a balance, but still you're getting these black areas is where the texture will remain, and these are the areas where you'll get the texture back. So this is a lot better than replacing this whole box with the blurred version. So this is what I'm doing here, and this is why this is necessary. And so yeah, so after I get the edges, I make the edges thicker by applying a dilation operation. So dilation, when you apply a morphological operation such as dilation, it dilates the white part of the image and makes it a lot thicker, like you just saw here. And when I get the mask, a dilated mask back, then what I'm going to do next is use this mask and do this. So this is saying replace all the parts of the original umbrella image with the blurred version, but only replace those parts where the mask is 1. So only replace the parts where the like the mask is not 0, where the mask is not black. So I'm saying here, replace the white parts of this of the original image with this blurred version. So this is what I'm saying here. So this is all done by just like this line of code. Now I have this umbrella ROI, which is selectively operated in a way that like only the umbrella edges part are like blurred. The rest of the the areas, the black areas here are retained just like in the original image. So now what I'm going to do is call this part again and then replace it with this umbrella. So for the demonstration sake, I'm also showing you the blurred version where I just copy paste that, and the umbrella version where I selectively blur out the umbrella and retain the texture. So this is what this looks like. Let me uncomment this and run this. So this is the the image where I retain the texture. As you can see, here's a texture here, and there's some texture here, here's some texture here. So this is the original texture that is being remained while the umbrella is completely removed. So and this is this version where we also remove the texture. Some people might prefer this, but anyways, both of them I think look appropriate. I would probably go for this one because it retains the texture a lot. So this is a lot useful. You can still tune this, change the values of iterations, change the kernel size, look at a lot more texture back. So there's that. So anyways, once we're done with that, now what we're going to do is read a logo. So I have a logo of Bleed AI here in this media folder, bleedai.png, and I'm reading it in here. I'm calling it design image. So this is the logo image that I want to imprint on this piece here. So now what I'm going to do is get the width and the height of the logo and then resize it accordingly, according to this ROI size. So because I want to overlay on top of here, so I need to adjust the logo size so that it can display properly on that ROI box. So after that, I'm gonna call canny edge detection again, but this time on this design mask. So I'm looking to extract all the edge or skeleton information of that logo. And then I'm going to perform a dilation again, and this time I'm going to perform it with a 3x3 kernel and only do an iteration of 1. And then I'm going to do some median blurring to smooth out outline of the logo, and then I'm going to invert the mask and then display it. I'm going to show each and everything why I'm doing those things. So this is the original image I got. So it's not exactly the original image, it's a resized version, because I significantly resized the whole logo, which was a lot bigger. So this, and you're seeing some artifacts here, some pixelations there. So if this was an SVG image and I resized accordingly, so you won't see these pixelations on the edges, because these pixelations are there, which is the reason I'm doing this blurring here. And this blurring smoothes out the edges here. So if I in fact get rid of this blurring, you'll see a lot curvy edges here, and I don't prefer this. I rather work with smoother edges. So this is what I get when I apply blur to the final image. And the reason I'm applying dilation is to again get a better mask at the end. So if I get rid of the dilation, you'll see something like this. I mean, just let me, for the sake of this, let me get rid of the blur, and yeah, so you'll get something like this. It's a lot thinner. I don't like this that much because I want the logo to be vivid, clear in the whole final meme. So that is why I want to make this somewhat thick, and not too thick, but somewhat thick. So this is why I'm dilating the edge detection result, which is this one, and then to get rid of the edges, I'm just applying median blur. So this is what I'm doing, doing these things. And obviously when you do canny edge detection, you have to specify the thresholds. There are two different thresholds, and there's a very interesting theory behind this. I've covered this in a lot of detail in my course, my image processing course, which is a 3-month course. So so it's really interesting. So after I get this, let me just run this again to get the final mask out. So this is the design mask. Now the only thing that is remaining is take this mask and display it on top of that on here. So that is all. I need to merge this image and with this image. So that is all I need to do, and this is exactly what I'm going to do here. So here I'm like reading the output candy image back, getting the height and the width, and then I'm extracting the ROI. So this is the ROI from the original image. I'm talking about this sort of an ROI. Let me like, I think I'm displaying each single step here. So yeah. Why not I just run this and show you how this looks like. So this is the ROI which I'm extracting. This is the ROI that contains the texture where the original umbrella was before. And remember, I replaced the umbrella, got rid of it, but while retaining the texture. So this is the ROI which I'm extracting here from the original image. So for that, I specify some value. You can also hard code the exact coordinates, but I feel it's much better if you work with this, because this way you can work with multiple images with different sizes and so on. So this is a code that would not break when you're working with different logos or different memes and whatnot. So anyways, once you have this ROI, I will modify it. And modifying it in the sense that I will do something like this. So I'll create a mask. So where the black part of the where I'm going to use this design mask, and I'm going to specify these are the parts which I'm going to replace with the resultant image. So and so what will happen now is that I'll use this image and replace only the parts that are highlighted, and while retain these parts of the original image. So let me further clarify this. So here I create a modified ROI, a copy of it, and then here I merge the design mask 3 times to create a 3-channel image. And this is because I will be comparing these two different images. This one is a binary mask, binary black and white single channel mask, and this one is a colored 3-channel mask, and I can't equate both of them unless they have equal channels. So this is the reason I create I convert this binary black and white mask into a 3-channel mask. And you can do this in multiple ways. I can use cv2.merge, insert the mask 3 times, or I can go from use convert color method in OpenCV and say convert color gray to BGR. So this is also another way, and I can also expand the axis using NumPy. So there are multiple ways to take a single channel binary image and convert it into a 3-channel image. So this is what I'm doing. This is a black and white binary mask that I'll be using. So this is what I do now. I take the modified ROI, and I tell that wherever the design mask is 0, wherever the design mask is black. So I'm saying take this design mask, this is the mask. Wherever there is black here, which are these parts, replace those parts, only those parts, with the original with the design mask image. So I'm saying wherever there is black present, replace it with this part. So replace it, paste this original image on those parts only. So we're only modifying those parts of the original image. And once we have a modified ROI, I'm now instead of directly replacing it with the image, I'm going to selectively merge it. So this is a nice blending technique. Instead of hard coding it on pasting it directly on here, I'm going to blend it. So I'm saying that retain 80% of the original ROI, but blend 20% of the modified ROI. So this is the modified ROI. This is the original ROI. I'm saying merge these two images, but use 80% of this image and 20% of this image to get this resultant image. So this is what entirely happening in this piece of line. You can also use this, but this doesn't look that much original. By using some sort of CV to advertisement method, you can selectively blend in a way that feels more authentic. So yeah, like I said, you can even take this further and do more image processing to get more even better realistic results. Anyways, for now, I'm gonna go along with just this resultant image, and then I'm displaying all of these 3 snippets here. And the final step right now, the final step that remains is that I'm gonna take this box, this ROI resultant image box, and replace it here. So I'm gonna just paste this ROI box here. So that is all I need to do in the final step. So here's what's happening here. So yeah. let me show you the result here. So yeah, here's the complete, like single line remaining. I'm taking the original part where the like the umbrella, where I like got rid of the umbrella, and then I'm telling it like equal it with this resultant image. So this is the resultant image, and then like what I do now is that I like take the output image which contains the candy part of the image and the person part of the image, and then I like change the candy part of the image, output candy. So yeah, and then I display the final results, and so this is what this looks like. So this is the output final image, which contains the logo. It's looking pretty neat and like somewhat like authentic. Like I said, you can even improve further upon these results. So just to recap again, I like took the candy part of the image, which is the second half of the image, replaced the resultant ROI box, and I pasted here. And then what I did is that I took the original output image, which is the full image, which contains the candy part and this person part, and then I said replace the original candy part of the image with the new modified candy part, which I just where the logo is present. So then I get the full image, and this is the final image which has been modified, like and completed, and then I'm displaying the results. So every single step, I think I've like explained in a somewhat a lot detail. And if you didn't understand like any part, you can ask me in the comments, or you like go over that part again. And I'm pretty confident if you go over that part and watch it again, you'll be sure of the whole process. So anyways, right now like I'm done with this result. I'll show you a couple of more logos which I just like took off the internet, and it worked really fine on the first try. I didn't even needed to tune any values. So it's really cool that it generalizes to different logos. So here's another logo. This is a Batman image, and let me show you the results here. So yeah, this is the original image, and this is the design mask. This is like already contains an alpha channel. So and yeah, so this is the resultant image, and then we get this final image. It looks pretty cool. Let's run another image. So right now again, so yeah, this is the Android logo which I'm trying, and yeah, it's cool. We can resize this Android logo and make it bigger. So we can do that. It's just like changing a single line of code. And this is the final image. This is the Donald Trump image, and I just I was trying to find a much cooler version than this one, but like like this one was worked fine. So yeah, these are the like final results of this image. And so yeah, this is our code. You can make sure to download it from the link in the description. If you enjoyed this tutorial, please make sure to like this video and subscribe to my channel. More interesting videos are coming soon, and I'll see you in the next video. Bye.